right. Can everybody hear me just fine? I think so. It's pretty easy. So my name's Damian Leopard. I am a solutions consultant with Orion Health and have been in the integration arena essentially for the last 20 plus years, both in healthcare and outside of healthcare. And so one of my first questions was kind of stolen already here. Actually, let me go to my first slide here. So what I wanted to do is give you a presentation on kind of at a high level, what is FHIR, where is it being used, and what kind of momentum is behind it already. And so how many people know more than how to spell it? Okay, excellent. And so how many of you are actually implementers? So people that are working in integration right now, okay? Clinicians, any clinicians? That's a bummer, because one of the neat things about the specification is that we're trying to make it a lot easier for clinicians to actually take part in. So FHIR. FHIR is the next generation standard for exchanging information from HL7. It is FHIR. It's not version 4, but some people actually have commented that if you used an alternate pronunciation of FHIR, like the German 4, it kind of harkens back to it is the next one. It's number 4. And from the very beginning, the whole goal in creating this was to make it easier and less expensive and adoptable by implementers. So everything's been considering how hard is it to actually implement. And if it's harder, we're gonna try and take an easier route for that specifically. So since a lot of you are actually in the implementation side or the integration side, you know, for those of you who aren't, the way that we exchange data today are using a set of standards. A lot of these have been around for a very long time, and we're already starting to see that FHIR is being adopted. So if we can use our first FHIR pun, it's kindling. So starting to smolder. Yeah. So maybe there will be a door prize for who can count the number of FHIR puns by the end of the day. So kind of from an HL7 perspective, the standards that they've been going out, you know, if we go all the way back to 1987 when V2 came out, it took a while. Things evolved a little bit. We ended up with V3 coming into focus around 1995, and it took a really long time to get to the CDA. And that was around for a bit, and now we're starting to see that evolution, that next generation or HL7 V4 FHIR coming out. If we look back to, I'm sorry, I tend to move around a little bit, and I'm trying not to move from the mic here. But if we look back to V2, it was not particularly easy to read. I wanted to find an eye chart icon to include on this slide, because you'd go cross-eyed counting the pipes to figure out where data was. And the messages themselves were event-driven, so it was just telling somebody about something that happened. Wasn't very easy to read, but it also didn't transmit more than just something happened. Somebody got admitted, somebody got discharged. A scheduling appointment was made. So we wanted to be able to create a larger viewpoint and be able to express more information, you know, things like historical information, and that was the birth of V3 and CDA, and it was based around documents as opposed to messages and events. It was very complex. It required, you know, I've heard people talk about it needing to have a degree in informatics to understand. It wasn't just even simple XML, it was complex XML, wasn't easy to read, and therefore didn't get as much traction as perhaps it might have otherwise. So if we kind of look back, looking back to that timeline, in 2011, HL7 and a number of organizations kind of got together and looked at, what is it that we need to do? How can we accommodate exchanging information with all of the new types of informations that are coming around, an incredible increase of the amount of healthcare information that we want to be able to share, some of the new trends around being able to provide precision medicine and population health, and make it something that an average person could actually implement. We don't want it to be very complex, and they tasked a number of folks with coming up with a new look at that. And so if we look at kind of the three different ones that we've talked about from a messaging structure, V2 was just too small, didn't express enough information. The CCD and the CCDA were too big, and so we like to think that, like Goldilocks, FHIR is just right. So if we come back to an overview of what FHIR is at its core, so it's an acronym for Fast Healthcare Interoperability Resources. And from the very get-go, when Graham Grieve created an initial concept of R4H, or Resources for Health, and kind of presented that back, it was very quickly adopted. It was something that was easy to understand, and it kind of got reborn as FHIR, which was a great name so that we could have all of those puns like kindling, sparking, et cetera. And it was built around a set of standardized APIs. So it's common architecture, things that are being used outside of healthcare. It's very easy to read. So when we actually get to looking at some of the various pieces, you can see just looking at it. You don't need a lot of expertise in the messaging structure or even in the domain of how you're trying to implement it to be able to understand what types of things are being exchanged. And it's meant to make it easier to exchange a lot more information and have a common set of messages and means by which you can actually exchange that information. And I think that we'll hear a lot more throughout the day, but I wanted to talk a little bit about some of that endorsement and support from the implementation community and the vendor community. So there's already a lot of support. So people have gotten together and said, you know what, this makes a lot of sense, and we're going to try to make sure that we move forward in a way that everybody can make use of this. And some projects like the Project Argonaut came out of that. So again, coming back to that historical timeline for FHIR itself, so the momentum is actually going a lot faster than some of the previous standards that have been out there. So that fresh look came out in 2011, and the first draft was out, and actually the very first Connectathon. So I haven't talked about the Connectathons before, but the Connectathons were the group of people. So this was meant to be an iterative design and check and see what works and what doesn't. So the Connectathons allowed groups of implementers and standards developers and designers to get together and say, hey, is this going to work? And do that in very short bites. And in 2014, the first draft standard for trial use was released, and a lot of folks started to use it right away. There was almost instant adoption. Now, obviously, those were people that were looking at, how do I do this? How is it going to work for me? It wasn't a group of folks that were ready to build their production applications. It didn't go into production right away. But then just a few Connectathons later, we had draft standard for trial use number 2. And that had extended a lot of the things. They made some course corrections with that. So some of the underlying technologies were abandoned or realigned at that point. And if you look kind of at that orange line there, that's kind of where we are now. And we'll hear this a couple more times throughout my presentation, but essentially at this point we're thinking that it's more of a working standard. So it's not done, but it's no longer in draft. The next standard release, which will be out shortly, is expected to be, a functioning standard. So what are some of those benefits of having something that is built on those types of principles? So it's a familiar set of tools. So we're using the technology, the underpinnings that a lot of the rest of industries outside of healthcare are using. So the folks that actually have to do this understand those technologies. They're actually even a little excited to make use of them, instead of having to go back and figure out how to support something that is either incredibly complex, like the CCDA, which isn't going away, but making use of all of those complex structures, or something like X12 that is based on standards that came out in the 50s and 60s. Now they can use what everybody else is using. It's very common making use of the XML format and JSON. And JSON is that JavaScript object notation object. It's very lightweight. It's easy to use. And common technologies like everyone on the web is using, whether you're Salesforce or Google or Facebook. All of those are using SSL and OAuth, and we're going to create a pre-designed set of APIs, and all of those are available completely for download. It's an open source standard. You can go to the HL7 website and download absolutely everything. You can read about not only what it is, how to implement it, but there are full example implementations. So you can just go down and see, this is exactly what a resource looks like. This is exactly how I would configure my API. And the community is very supportive of this. So if you go out and you look at online forums, there's listservs, you can ask questions, you can get answers almost immediately. And once you're ready to start trying it out on your own, there are services that you can go out and actually test what you were thinking. And some of those tools, because it is built around that easy technology, some of the things that you need to test might only be a browser. So you could just start playing with it immediately. And it is very mobile friendly. So as we start to increase the availability of applications that go out to consumers, things like the tracking devices or tracking systems or patient engagement applications on mobile devices, the technology that we're using is the same set that you would use for any other, whether it's your banking applications or Yelp, et cetera. So those are a lot of things, a lot of the benefits around what the implementers get, but it really allows a lot of benefits for even the clinicians and the patients themselves, because it really allows for a faster access and easier access to those pieces of data. And even clinicians can, if they were to see it, they could start to understand or even say, these are the types of things. So there's a standard set of tooling that you can go out and be able to say, okay, this is the type of information that I want to see. These are the types of profiles of information that I want to see. And it's a very simple and easy to use, easy to understand way of essentially describing what it is you want to show up in the data that you're using. And it enables the patients to actually go out and reach out and ask for their own healthcare information and be able to access it and interact with it. And finally, as we'll see throughout the day today, a lot of the vendors are already committed to FHIR. They've made plans. It's in their roadmap. They're developing and designing systems today to make use of FHIR. So FHIR is built around those resources. So there are a whole slew of them that have already been defined and described. There are some of them listed here. I like to think of them as either puzzle pieces or building blocks of information. They're very well defined, and they're relatively self-descriptive. So if you look at something like a patient or a procedure, you know what it is. It's self-descriptive. And there are other sets. These are some of the clinical ones out there. But from an overview perspective, if we look at an example, if we start here at the top, we have some descriptive information, or what we call metadata, about that resource itself. And then one of the neat things about this, I mentioned it briefly with looking at those examples of V2 and V3, they weren't very easy to read. So we introduced the ability to create a summary. So you can actually insert this summary that is a narrative of what is included here. So it's human readable, so even if I were that clinician or that patient, if I happened to end up seeing this in its raw form, I'd still be able to understand the information that was meant to be shared. The next section there is the extensions. So extensions are a prescribed way of being able to add additional information. So if you look back to things like V2, we had Z segments, and Z segments were hard to understand. You didn't know what was in them necessarily unless you went and asked somebody. So from an implementer's perspective, if we get this and we see the extension, one of the required elements of an extension is a URL. And when you go to that URL, it will describe exactly what data is in that extension itself. And there are a number of examples of that also out on the FHIR website. Go and look at, examine, interact with. And then the data that's going to be a part of that resource, the standard structure, the one that's been defined by the community at large, will come after that. And the one that we see here is actually an XML format. A lot of the implementations that I've seen, although they will support XML, often are now moving more and more towards JSON. So it's an either or both in terms of the formats that you want to support. And then we can take those individual building blocks or puzzle pieces and start to build a complete picture of the information that we want to describe or share across the community. And we do that by kind of creating references between each one of those building blocks. So you can see in here, this one has a procedure that was done by a particular practitioner at a particular time to a particular patient, and then has a specific report as it came out from that. So when we talk about messages, so I was talking a little bit about HL7V2, we're being able to notify people about an event that happened. And then we have documents, so we want to be able to share those documents like a discharge summary or a continuation of care document. So those are complete pictures, or we might want to be able to update or create or query or interact with information that an application or a server has, and then we also may want to be able to reach out for things like terminology services and translate or transform those codes. And so the specification was meant to kind of include all of those different paradigms, whether I wanted to notify somebody or ask somebody about, hey, do you know about this patient, or do you have this patient's identifier? Or I wanted to be able to exchange information as a discharge summary, for example. All of those are built in there. So that the API itself is built around REST. REST is the common tool set that's available across the internet itself, and it can be secured. So it's using the same standards with HTTPS. It's something that that was specifically called out when looking at, hey, what do we need for the next set of standards? We need some type of API. And so REST was chosen because it's being used everywhere. It's very lightweight, it's very easy to use, and it does all of those same types of actions, so those verbs of create, read, update, delete, etc. So documents themselves, so the same way that we had an individual resource or a message, we're going to build those individual pieces together. So we're going to create that composition, and we're going to include or describe all of the various pieces of that information that we want to exchange, whether that's a message notifying about an event such as an admission or a discharge or a scheduling event, or that summary of care or history of care, that full document, everything that we want to send out. And much like the resources, you can go out on the FHIR website, the HL7 website, and download examples of these, see actual examples of those documents and those messages. So the last piece here is it doesn't really matter whether I'm talking about querying for information using that search capability, or accessing a service to do some terminology mapping, or notifying somebody of an event using that messaging infrastructure, or exchanging a more comprehensive view of the clinical information in a document form. All of the resources stay the same. They're not going to change from one paradigm to the next. So it's a common set of tools that you only have to learn once. You don't need to look at any other things. You're going to be able to understand each individual one. So it's the same resources. So it's not a panacea. There is no magic bullet. There are a number of challenges that still exist. I get asked all the time, well, how do I map from my existing standard, whatever that is, whether it's a V2 message or a CDA, how do I map from those existing data sources, even if it's something like, we're seeing more and more interest from the payer community to be able to exchange financial information. How do I go from my X12 events to FHIR itself? And there's still a lot of disagreement across those different areas of, how do I structure this specifically? How do I want to describe this? How do I do things like security? The standard that HL7 has put forth says that it must be secured. And it recommends that you use things like SSL and TLS. And a lot of the people who are putting together implementation guidelines have said, we're going to use OAuth. And OAuth is a common way to secure and authenticate in the industries outside of healthcare. So we think it's something that we can do. But not everybody has said, yep, that is for sure the way that we want to do. And really, the other piece is how do we really understand where it fits or what things aren't going away? So there have been a lot of things like, well, the CDA is a requirement. How are we going to move that? Where are we going to put it within FHIR? How are we going to exchange that information? And one of the simplest answers is there's a place for some of those. And there are other groups that are looking at, okay, where are those lines of delineation? Where do I continue to use an existing standard? And how do I make that standard work kind of cooperatively with FHIR itself? And then finally, it's not fully mature. It still is evolving. It's something that we're working on all the time, that we're getting more feedback from folks that are implementing it all the time, and kind of making adjustments and course corrections in the way that it's going. And if we kind of start thinking about where are we in the adoption cycle, so if we look at the Gartner curve here, whether are we still climbing towards this peak of inflated expectations? I think so, because I think that people are still looking at more ways that we can use the standard, and more models and more resources, and more implementation guides. So I think that we're still going there, but you know, I don't know what happens when we end up in a trough of disillusionment, when we figure out, well, FHIR can't do this for me, or it can't do that for me. It's not going to answer the question that I particularly wanted to have an answer. But we'll see how that goes. So we are building a lot of momentum. So when the standard itself has kind of sparked that application innovation. So when we start to look back across the application development community, or even the folks that are coming up with ideas of what types of applications do I want, and how do I want to share those pieces of data, FHIR is kind of saying, well, if it's always predictable, if I'm always calling the same types of things, it doesn't matter whether I'm querying for information from one EMR, or I'm connecting to a FHIR repository, all of my actions are very predictable. It's very similar. It's the same every time, and I know what I'm going to get back. And the tools have been set up in such a way that the servers themselves, so when you interact with those APIs, they have to tell you, they have to describe, they have a conformance statement that says, you know, these are the services that I can provide, and these are the profiles that I support, and these are the types of services and operations that I support. So you can go out and figure out, hey, what else is available? What other things that can I consume, or what can I expect not to see from a particular system or application stack? And it's being used to actually create entire frameworks. You know, the folks at Boston Children's Hospital have created their own standard around FHIR called SMART, and SMART's enabling them to create individual applications to interact with that help, and whether that's for the clinicians and the healthcare providers, and whether they're working on premise or out in the field, they'll have access to that patient data, and the healthcare information built around those applications. And so what does that mean? So it means that as I'm thinking about what's the next best thing that I can come up with that enables either, you know, better patient care, or more patient engagement, or empowering things by using analytics, I have access to that, and I have a common way of getting it. So I can build my application and expect that it's going to be, relatively speaking anyway, implementation agnostic. So I can go out and make use of that against all of the different sources of data across my ecosystem. So I don't have to worry about how am I going to get that data, and how am I going to respond back and send that back to the systems that I'm interacting with, because I have a common way of doing that. So I mentioned earlier, and in this previous slide, you know, there's some momentum behind this. So there are actual real world, in production systems that are making use of the FHIR standard. Some of them internationally have even been based on draft standard version 1. So there wasn't even, you know, they were committed to it immediately. They said, this does enough of what I need, and I know I may need to rework things a little bit, but immediately I can make use of it. And I think that we'll hear throughout the day today, in the presentations that follow throughout the workshop, about a whole lot more of those examples. So if we try to wrap up and summarize that introduction, the FHIR itself is now a working interoperability standard that is enabling the community to really become more involved. because it's simple enough that I can look at those resources, I can read that document, even if I see it in its raw form, I can help interact with the description or the design of what those resources and what those profiles need to contain. And we have a huge community of folks that are actually working on reference implementations and creating implementation guides themselves. There are a number of them, and a lot of them are working hand in hand with FHIR to make sure that things are moving forward, things are getting faster and easier. So FHIR really is disrupting the way that we are sharing information in the healthcare space. And, you know, to follow up with our last FHIR pun in my presentation, healthcare is really catching on fire. So we're getting a lot of momentum behind it. So I have about 4 minutes left. Are there any questions from a high level or things that you wanted me to go back and touch on? Anyone? No? Oh, we got one here.
Is that, oh, excuse me. Is there built-in translation into the standard, or is it just sort of a decision that needs to be made going into it?
So that's a very interesting question for folks that might have missed the beginning of that before the mic came over. The question was, I had mentioned that you can use XML or JSON to build those. And is there some preference, or is there anything built in to kind of translate between the two? Within the specification, no. And in many cases at the server level, the expectation is that the server will be able to respond back with either. So it will support both XML and JSON. And a lot of the things that I've seen to this point, the calling or the caller, because a lot of the implementations right now are about querying for information or just being able to respond to those queries to bring things out. So I query against those APIs and I'll get information back, and I request whether I want it in XML or JSON. Now, there are a lot of products out there that, I mean, you'll see exact examples. So you'll be able to see an RDF or a WSDL or an XSD or an actual example of an XML and JSON of every one of those individual resources. And then there are a number of products. So for example, Rhapsody, Orion's integration engine, supports the ability of going back and forth between those two products. And I'm sure others do as well. Any other questions? Yep.
This goes down to the granularity of it. If I am calling from one system to another for a problem list, naturally it's going to return a list of problems. But if I'm asking for a list of active problems, is it going to be able to parse those out? Or is there going to be a dependency on the sending system to have the intelligence to know what I'm asking for and only send me the active problems?
So I think a lot of that comes down to the specific implementations of those. So when I actually do that query, the query itself, the searching or the constraining, is built into the API. So I can actually say, give me the problems that also have this attribute of they're active. So when I ask for them, I can specifically say I only want the active ones. Now, the other piece of that, and I didn't cover it specifically in the slides here, is that profiling, but I made mention of it. So profiling allows you to put together exactly what you want to expect around something. So you could say, for example, I want, when I'm querying for this problem list. And I'm not saying that that specific one is there, but I can say I only want active ones. I only want one instance of this potentially repeating field. So you can describe that. Exactly how is it that I want to receive or populate a specific set of resources or messages or documents. Does that make sense?
It does. So, but the receiving system have to have the intelligence to break down the request statement and then actually build it, respond appropriately.
That's correct.
By standard to respond back. The receiving system have to build that return message.
That's correct. So the responding server would need to be able to put together that message specifically. And there are some examples, so you could go and test them right now. So I've actually gone over at this point, so I'll close and thank you all. Ooh.